The topic is using the rational zero theorem to factor completely. So let's try to do this example. Factor completely f of x equal to x cubed minus 3x squared minus 11x plus 6. So let's look at the rational zero theorem. We're trying to use it. The rational zero theorem says if f of x is equal to an x to the n all the way to a0, and if p over q is a 0 of f, then p is a factor of a0, the constant, and q is a factor of an, the coefficient of the highest degree term. Alright, so in other words here, the possible rational zeros, p comes from the factors of 6, which is minus plus 1, minus plus 2, minus plus 3, minus plus 6, and q comes from the factors of 2, which is minus plus 1, minus plus 2. So the possible rational zeros will be, so if you multiply all the p's divided by the q's will give us minus plus 1, minus plus 2, minus plus 3, minus plus 6. And then if you divide all the p's by minus and plus 2, you will get minus plus 1/2, and then minus plus 3 over 2. Alright, so of course we want to try always the integers, like 1, minus 1, 2, minus 2. So let's plug in 1. F of 1 will be equal to 2 times 1 cubed minus 3 times 1 squared minus 11 times 1 plus 6. If we add all that stuff, 2 minus 3, so it's going to be minus 6, which is not equal to 0, so we can't use it. Let's do f of negative 1. So f of negative 1 is what? 2, negative 1 cubed, minus 3, negative 1 squared, minus 11, negative 1 plus 6. So that would be minus 2, minus 3, which is minus 5, plus 11, plus 6. That's 12. Not equal to 0 also. Can't use it. F of 2. 2 times 2 cubed minus 3, 2 squared, minus 11, 2 plus 6. That would be 16 minus 12 minus 22 plus 6. 16, 22. Yep, that's a 0. Well, actually, no, it's not a 0. 16 plus 6, 22. Yep, not equal 0, right? Now, what do we need to do? F of negative 2. F of negative 2 is 2 times negative 2 cubed minus 3 negative 2 squared minus 11 negative 2 plus 6. That would be equal minus 16 minus 12 plus 22 plus 6, and that's a 0. So now we know that x minus the c is a factor. In other words, x minus minus 2, which is plus 2, is a factor of f of x. Since it's a factor, then we can divide by x plus 2, we're going to get a 0. So dividing, so let's use synthetic. Dividing, so we're going to use a negative 2. We're going to put the coefficient of f, which is 2, negative 3, negative 11, 6. Right? Drop the 2, you get a 2. 2 times negative 2 is 2 times negative 2 is negative 4. Negative 3 plus negative 4 is negative 7. Multiply by negative 2, you get 14. You add, you get 3. 3 times negative 2 is negative 6. You get a 0. This is how we know we didn't make a mistake. The remainder will be a 0. Now, not only that, since this is degree 3, this will be degree 2. So 2x squared minus 7x plus 3. So now we can say that f of x is equal x plus 2, our factor of 2x squared minus 7x plus 3. Now, instead of plugging the numbers, usually once we get to the quadratic one, it's always nice to use complete factor theorem. What does the complete factor theorem says? All it says, plus 2, that you can factor this, factor the 2, this is an, factor 2, and it's going to be x minus the first 0, and then x minus the second 0 of this function. How do we find the zeros? It's pretty easy. Just set 2x squared minus 7x plus 3 equals 0 and solve for x. So if we use quadratic formula, we'll get 7 minus plus square root. Minus 7 squared is 49. Minus 4 times 2 times 3, so minus 24 over 2a, which is 4. So x will be equal 7 minus square root of 25, which is 5. So 7 minus 5 over 4. 7 plus 5 over 4. This is going to give us 1/2. And 8, 12 over 4, 12, 7 plus 5, 12 over 4, which is 3. Right, so the answer will be 1/2 here and 3 here. So all we need to do now is rewrite it, put the 2 here, and we're done. So f of x is equal to x plus 2, x minus half, and then x minus 3. And that's it for this example.